everyone, welcome back. This is lesson 8.8, solving radical equations and inequalities. All right, as a warm-up and review, let's do some of these problems. The first problem tells us to add, but we do not have the same thing in our radicals, so we cannot add them right now. But when I look at this, I know 27 is made up of 3 times 3 times 3 times x. And since my index is an understood 2, I can take one set of 3's out, so 3. So that's going to leave us with 6 square root of 3x. Again, for my 12, I know 12 is made up of 4 times 3, and 4 is 2 times 2 times 3x. Again, my index is 2, so I can circle 2. 2 times 3 is 6. And again, square root of 3x. Now that my bases are the same in my radical, I can go ahead and add together 6 plus 6 and get 12 square root of 3x. All right, for number 2, 72, I know is made up of 9 times 8. And 9 is 3 times 3, and 8 is 2 times 2 times 2. And then I have 5 y's. You do not have to write them out this way. I just am doing it so that you can actually see what's happening. Notice my index up here was 2, so I'm going to circle everything in groups of 2. I can take out a 3 and a 2, that's 6. And 2 y's, y squared, that leaves me with just a 2y and a final answer of 6y squared times the square root of 2y. All right, so our next problem, number 3, we're just to write the expression in radical form. So on this one, let's just take our x plus 2, and it's raised to the third power. And it says to go ahead and this root sign here tells us that another way of writing that would be 1/3. All right, and remember our power property. 3 times 1/3 equals 3 over 3. 3 over 3 is 1. So our exponent is really just 1. And anything to the exponent of 1 is itself. So our answer is x plus 2. On number 4, we're going to just go ahead and simplify this again. So 248 is made up as 8 times 6. So I'm going to go ahead and write my 8. 2 times 2 times 2. And my 6 is 2 times 3, and my y. Again, my index is 2, so I'm just going to circle up groups of 2, and that's all I have. So I'm going to have 4 times the square root of 6y. All right, next one. Now this one is really, really simple. Don't get freaked out. Anything to the 1/2 power is just the same as writing it like square root of x plus 6. And now let's look at this one. What I want you to think of first is get this to be a 1 over a fraction. In this case, it's going to be 1 over 5. So we're going to say 3y plus 4 to the 1/5 power times, or raised to the third power. Notice that 1/5 times 3 is the same as 3 over 5. So now that I have this, I can see that my answer is going to be the 5th root. I took my index and put it over here, times 3y plus 4 raised to the third power. All right, so your objective for today, you're going to be able to solve radical equations and inequalities, and your only vocabulary is radical equation and radical inequality. Okay, a radical equation contains a variable with a radical. And recall when we were solving quadratic equations, we could do that by taking the square root of both sides. So for example, sometimes we ended up with x squared equals 36. And so in order to get x by itself, x equals something, we actually ended up squaring both sides and would get x equals 6. All right, so now we're going to be able to do it the same way, but just going backwards. So radical equations can be solved by raising both sides to a power. So this time we're going to actually raise it to a power instead of square root it. All right, so the steps that we're going to need to do is, first of all, we want to get our radical all by itself. And so to do that, we're going to, like in this example case, just subtract 2 from both sides. And then in this case, it says to raise both sides of the equation to the power equal to the index of the radical. So if my radical was 3, I want to raise everything to the third power. And so 2 to the third power is 8, and we can see that this ends up 8. I just want to look at that piece a little bit more. 3 to the x, and all of that was raised to the third power. So let's remember, when we see this radical sign, we just take the index here and say that's the same as x to the 1/3. And then it tells us to go ahead and multiply by 3, because what that does is 3 times 1/3 equals 3 over 3, which equals 1. So that just leaves us with x to the 1 power equals x. So I just want to make sure that you really understood that. And then obviously 2 to the 3rd power is 8. Okay, so let's keep going. Remember, for a square root, the index of the radical is 2. So understood 2. All right, so here's an example for you to try on your own. The first thing we want to do to solve this is get the radical all by itself. So we're going to isolate our radical by subtracting 5 from both sides. So when we do that, we end up with square root of x plus 1 equals 11. Now, all we have to do at this point is square both sides. And by squaring, we actually are going to get rid of this radical sign. So we end up with x plus 1 equals 121. And x equals 120. So then the only thing you have to do at this point is you could just check it, fill in 120, and we end up that 16 equals 16, which is true, so you know you did it right. All right, another example. This time, notice that our index is 3, so we're going to have to just use a little bit of common sense here. So first of all, let's isolate our radical to get it by itself, and we just do that by dividing everything by 7. So these two will go away. 84 divided by 7 is 12. All right, and so now we want to get rid of our radical sign here. So this was to the cube, a third, so we want to cube both sides. So by doing this, I end up having, this is actually saying 5x minus 7 to the 1/3 power, and now we're going to multiply or cube it. And so 3 times 1 is 3 over 3, which equals 1. So now we just have 5x minus 7 to the 1st power, so that's just 5x minus 7. And 12 to the 3rd power is 1,728. Again, so simplify again by adding 7 to both sides and then dividing by 5, and we have x equals 347. The great thing about math is that we can actually check our work, and so by checking to make sure everything checks out, and sure enough, 84 equals 84, so the problem was done correctly. All right, so try this one on your own. Turn your video off and give it a try real quick. Okay, so I hope the first thing you remember to do is go ahead and isolate your radical by itself. So hopefully you subtracted 4 from both sides. And we get the square root of x minus 1 equals 1. And notice our index is 2, so all we have to do is square both sides now. So, and when we do that, we end up with x minus 1 equals 1. Subtract 1 from both sides, or add 1 to both sides, we get x equals 2. We can go ahead and check. The great thing about math is you can check, and sure enough, when you substitute 2 in for x, you get 5 equals 5, so you did the problem correct. All right, do another one on your own. Remember, this time we've got a 3 as our index, so pay attention to that. Turn your video off and turn it back on when you're finished. Okay, so hopefully you knew it was already isolated by itself, so all we have to do is cube both sides. Once we do that, our radical sign goes away, and we just have 3x minus 4 equals 8. Easy to solve for x at that point. Go ahead and check, and when you check, you see that 2 equals 2 when we substitute 4 in place of our x here, and sure enough, you did it right. All right, try this one on your own. Now, be careful on this one. Remember, we have an index of 2, but I have a 6 on this side. So the very first thing I need to do to isolate our radical is divide both sides by 6. All right, and so now I'm going to have x plus 10 equals 7. And so since my index here was 2, I'm going to square both sides. And when I do that, I end up with x plus 2 equals 49. And then I can solve for x easily and go ahead and check. And when I substitute 39 in, I end up with 42 equals 42, which is a true statement. So we know we did it right. All right, another example. This time we're going to have 2 radicals, but you're going to follow the exact same thing. So the first step that we want to do is go ahead and square both sides. Because our index here was 2, so all we have to do is square both sides. Now, this is where you want to be careful. Just be careful with this 3 that was out here, okay? The radical sign goes away, and that's fine. the 3x minus 2 stays, the radical goes away on that side. Just don't forget that that 3 has to get squared also. So this is where students make a lot of mistakes right there. But once you've done that, now you can just simplify. It's easy algebra that you've been doing for a long time now. And then you can just solve, and x ends up equaling 1. And of course, always go back and check. Since x was 1, we just substitute 1 in place of our x. And when you do, 3 equals 3, and it's done right. All right, so try this one on your own. Go ahead and turn your video off and give it a try. All right, I hope you found this one to be pretty easy. Remember, our index here is an understood 2, so we just need to square both sides. And when we do, don't forget to square your 3 also. So we end up with 8x plus 6 equals 9x, and now it's an easy algebra problem to solve. 6 equals x, and then you can do your checking by substituting 6 in for x, and we end up, don't get freaked out, but we end up with 3 square root of 6. And it's true on both sides, so you know you did it right. All right, here's another one. Try on your own. Be careful this time. We've got a cube here. So don't forget, you have to cube that 2. All right, turn your video off and try it. All right, hopefully you notice that when you cube both sides, this radical is going to go away. This is going to go away. When we cube 2, we get 8. So we end up with x plus 6 equals 8 times x minus 1. And then distribute and solve, and we find out that x equals 2. And of course, we always need to go to check. So substituting your 2 in place of x, and we see that 2 equals 2. And that is correct. So notice here, the cube root of 8 is what we ended up with. So we have to find 3 numbers that multiply together to get 8, which we know is 2 times 2 times 2. And since it was a cube, we have to circle all 3, and that's how we get our 2. And again, for 1, 1 times 1 times 1 is also 1. So 2 times 1 is 2. All right, raising each side of an equation to an even power may introduce extraneous solutions. So just like before, when we raise things to an even power, you could get some answers that aren't actually true. So you can use the intersect feature on a graphing calculator to find the point where the 2 curves intersect. I prefer just going about checking it algebraically, but I'm going to show you how to do it with your calculator too. Okay, so on this example, the first thing we're going to do is use our graphing calculator to solve this. So let y equals the square root of negative 3x plus 33, and let y2 be 5 minus x. All right, and notice we're just going to look for where they are equal. All right, and so when you do that, the point of intersection of our 2 is at x equals negative 1. I have a hard time seeing on my calculator and being able to count all my numbers accurately, so I prefer just doing second table and looking at the table to where the 2 x and y are equal to each other, and you will find that that is at x equals negative 1. All right, so that's one way to do it. The other method method of solving this is using algebra, which is the way I prefer doing it. It just seems easier for me. The first thing I need to do is go ahead and solve for x, so I'm going to square both sides. Now notice when I square both sides, I can't just say this is 25 minus x squared. That's wrong. I have to actually say 5 minus x, and then I have to actually multiply by foiling this out. Okay, so you're going to have to FOIL that out. This side, since there's a radical, I don't have to do any foiling on that side. Okay, so once I simplify it, I get 25 minus 10x plus x squared. Now I see that this x squared is going to tell me that I'm going to have a quadratic equation that I might be able to simplify. And so if I just write it in standard form, go ahead and add 3x to both sides and subtract 33 from both sides, I end up with 0 equals the following. Now that I have it in standard form, I can come up with 2 numbers that multiply together to get negative 8, add together to get negative 7. And I know that's going to be 8 times, actually negative 8 times positive 1. All right, and let me get rid of that negative sign there. All right, and so your actual problem is x minus 8, x plus 1. And so here's the thing, when we solve for 0, notice that I came up with x equals 8. But if you look on your calculator, you'll see that that was actually not 1. The only place where they intersect is at x equals negative 1. Now, all we have to do is check, and Okay, so continuing on so we can check with our extraneous answers, we're going to use algebra again and just substitute to check for our extraneous solutions. So we said that x could equal 8, and we also said that x could equal -1. So we're just going to substitute in place our 8 and a -1, and when we do with our 8, notice it says 3 equals -3, and that is not true. So we cannot use the 8, and when we substitute with -1, 6 equals 6, and that is true. So you need to be aware of that. So because x is equal to 8 is extraneous, the only solution is x equals -1. All right, so try this one on your own. Turn the video off and give it a try. In this one, we're just going to do the calculator method first. So using your graphing calculator, we'll let y1 equal this, and let y2 equal x plus 3. And then once you put it into your calculator, again, you can do your graph. I prefer to just go to second table and look at the table and find out when x and y are equal to each other, or I'm sorry, y1 and y2 are equal to each other. But you will see that the solution is x equals 1. All right, I also want you to try doing it the algebraic method. So go ahead and turn your video off if you haven't already and do it algebraically. All right, to solve this problem algebraically, we're going to first go ahead and square both sides. So once we do that, again, remember this is not equal to x squared plus 3 squared, which is 9. We have to actually write it out, x plus 3 times x plus 3, and FOIL that. And when you do, you end up with this equation. And we're going to rewrite it into standard form so it equals 0. Once we do that, find two numbers that multiply together to get -5, add together to get 4. And that is actually 5 and 1, and it's positive, so we're going to make it that way. So our factored out form is x plus 5, x minus 1. And that tells us that x is either going to equal, let's see, oh, there's a mistake. Oh, okay, x plus 5 equals 0 or x plus 1, so x equals -5 or x equals +1. So next we have to check it algebraically to see if there's any extraneous solutions. And so using algebra, we're going to substitute for our x, and in the first side we fill in with -5, and notice 2 does not equal -2, so that one cannot work. But when I fill in with x equals 1, 4 does equal 4, and that one does work. So because x equals -5 is extraneous, the only solution is x equals 1. All right, one more to try on your own. Turn your video off and give it a try. First of all, go with the calculator and then go algebraically. All right, so on this one, the first thing, since we're doing the calculator first, you just let y1 equal that and y2 equal this answer part. Just click table or graph, whichever one you like. And the graph intersects in 2 points. So there are actually going to be 2 solutions. So notice there's a point here and a point here. All right, so the solutions we see on our calculator are going to be x equals -4 and x equals 3. So the advantage to looking at the graph is that you can see that there's 2, so you don't just look and say find the -4 and then you miss out on this x equals 3 one. So there is an advantage to using the graph. I also like to go back and look at the table too. All right, using algebra to solve the same equation, you're going to square both sides. Again, remember we have to square both sides. All right, so when we do that, we're going to actually multiply by -x plus 4 and FOIL that. We end up with this problem. Hopefully you were able to find that. Then you want to write it in standard form, and then we have to factor -12 and 1, two numbers that multiply together to get -12 and add together to get 1. I know that's going to be a 4 and a 3, and the 1 is positive, so we're going to do it that way. So x plus 4 equals 0 times, x plus 4 times x minus 3, and we end up with x equals -4 or x equals 3, which is what you found out by looking at it at the calculator also. I do want you to know how to use both methods, particularly the algebra one. All right, so again, we can check it When we substitute for -4, we find out that 8 equals 8, which is true. And when we substitute using the 3, we end up with 1 equals 1, and that's also true. All right. To find a power, multiply the exponents. All right. So in this case, x plus 12 to the 1/2 power squared ends up being x plus 12 to the 1 power, which is just x plus 12. Okay, so let's solve this problem together. Notice that this time what I have is this is to the 1/3 power. So remember, that's just the same as rewriting in radical form like this, the cube root of 5x plus 7. All right, so once I've done that, now you could probably see, notice my index is 3, so if I cube both sides, I'm going to end up getting rid of that radical, and I just have to change my 3 raised to the 3rd power now. So once I've done that, I can simplify and end up with 5x plus 7 equals 27. Solving and factoring is pretty simple here. So we end up with 5x equals 20 and x equals 4. Okay, on this one, we're just going to skip the step of changing this to 4x plus 8 to the like this, and then going backwards and multiplying again. So all we're going to do this time is we could just raise both sides to the reciprocal power. So my reciprocal of 2 was 2, so if I multiply both sides by 2 here as the exponents, notice 1/2 times 2 is equal to 2 over 2, which equals 1. So we end up just having 4x plus 8 is equal to 4x squared. Because remember, when I squared this whole thing, 2 times 2 is 4. You can't forget that one too. All right, so now it's just an easy algebra problem for you to solve. We can factor out the 4. Now we just have to find two numbers that multiply together to get to -2, add together to -1. -2 times 1 is our answer. So here it is factored out for you. And once we've done that, we can solve and see that x is either going to equal 2 or x will equal -1. All right, and on this one, since we had to square everything, we might have some extraneous solutions. So let's use our substitution to check. And when we substitute with 2, we get 4 equals 4, so that's good. When we substitute our -1, we get -2 is equal to 2, and that is not correct. So the only solution is going to be x equals 2. Okay, go back and try this one on your own. Turn your video off and give it a try. All right, so the first thing that we need to do is notice that this is raised to the 1/3 power, so we can go ahead and write it in radical form here. And once I have it in radical form, then all I need to do is cube both sides. By doing that, I get rid of my radical sign, so I have x plus 5 equals 27. And now I can just solve for x, so x equals 22. All right, turn your video off and try this one on your own. Okay, again, on this one, we want to first of all raise both sides to the reciprocal power. And what that's going to do for us, when I multiply 1/2 times 2, I actually get 1. So this is just going to be the same, and then I'll have an x squared on the other side. So 2x plus 15 equals x squared. When we write it in standard form, now all we have to do is find two numbers that multiply together to get -15, add together to get -2. Now that's going to be a 5 and 3, so let's put our negative there. So we end up with x minus 5 times x plus 3. And solving for x, we see that x equals 5 or x equals -3. Okay, and again, since we squared things, we want to use substitution to check for extraneous solutions. So substituting our 5, we see that 5 does equal 5. That's great. But when we substitute our -3, 3 does not equal -3. So that one is extraneous. So the only solution is x equals 5. All right, try this one on your own. Turn your video off and give it a try. All right, so the first thing you might have seen is we have a half there. So we're going to raise both sides to the reciprocal power, which is 2. All right, so when I do that, you have to be really careful. Notice this square is going to deal with this, but it's also got to deal with this 3. So we actually end up with 9 times x plus 6 equals 81. At this point, we can just distribute our 9, and we can simplify pretty easy. So x equals 3. A radical inequality is an inequality that contains a variable with a radical. You can solve radical inequalities by graphing or using algebra. And remember, a radical expression with an even index and a negative radicand has no real roots. So if I said like square root of negative 25, I've got my 5 and a 5, but I also have to get a negative 1 in there, which is an imaginary. So that means there's no real roots for that. If it had been a cube root, like square root of negative 27, we can get negative 3 times negative 3 times negative 3, and that actually equals negative 27. But if it's even, we can't get there. All right, so we're going to solve this problem, and you can use a graph and a table first. So if you're using your graphing calculator, you'd let y1 equal this expression, y2 equal 9, and then you can look at it and see that in order for y1, we want to be less than y2 on your calculator. And notice at 9, it is equal to 9 because it said greater than, less than, or equal. So we can see this, and notice that the solution also at 3, because when 2 times 3 is 6 and 6 minus 6 is 0, that's we no longer have anything in here anymore. So our and then we end up with 3 is less than 9, which is true. So x has to be greater than 3 or less than 21. So you could see that in your calculator here. In order for this whole piece to be less than this line right here, because this line is our y2, which is equal to 9. So this is the only section that we're concerned about here in the green. All right, take a look at another one. Okay, so we're going to take the same problem again, and this time we're going to solve it using algebra, but we have to do two parts of this. We're going to have to consider this section, and we're going to have to consider the whole equation. So in order to first solve for x, we can square both sides, and when we square both sides and simplify, we end up with x is less than 21 or equal to 21. But we also have to pay attention to this section. So our second step of this problem is to just take the 2x minus 6, and we want that to be greater than or equal to 0. We don't want a negative inside our square root. We don't want it to be 2x minus 6. We don't want this to end up being negative, so we're going to set it equal to 0 or greater than. So the radicand cannot be negative, so once I've done that, I can solve for x, and I see that x has got to be greater than or equal to 3. So the final solution is going to be x is greater than or equal to 3, and x is less than or equal to 21, or it could just be written out like this. Try this one on your own, and then you will be done. Okay, so the first thing we want to do, if you do it the calculator method, you're going to use a table and a graph. Let y1 equal the first part and y2 equal the second part. Put it in your calculator, and when you see it, you're going to see that our section that we want is going to be right in here. All right, and so that is going to be at x equals 3, so x has got to be greater than 3, and we want it to be less than 5, and this section here is our 5, so this is our only area that we want. So the graph of y1 is at or below the graph of y2 for the values of x between 3 and 12. Notice that y1 is undefined when x is less than 3. All right, so there's our solution. All right, continuing on doing the algebra, the same problem using algebra. We're going to solve for x, so we're going to subtract 2 from both sides, square both sides, and then simplify. And that's pretty easy. So we have x is less than or equal to 12, which we had before. Now don't forget, we have to deal with this part inside of our radicand. So our second step is we're going to consider the radicand, and we want it to not be negative. So we're going to set it greater than or equal to 0. Once we do that, we see that x has to be greater than or equal to 3. So the solution is going to be x is greater than or equal to 3, and x is less than or equal to 12. Or you could rewrite it this direction. All right, and that's the end of lesson 8.8, solving radical equations and inequalities. You guys have a great day, and I'll see you soon. Bye.